Hello YouTube, today we're going to be learning how to write an operator equation for the current going through the top, or the I-top, given by this circuit here. Now you can approach this problem using differential equations. The method we're using is an algebraic method used to go around differential equations, which is supposed to make things a lot easier later down the line. So let's go through this problem. You should know how to use current dividers, voltage dividers, and know what impedance is a little bit. If you don't, look at my total impedance video on my circuits playlist. But let's jump into this video. So if you're trying to find the current going through the through that capacitor area on that right part of the circuit, you can write the operator equation simply by actually solving the problem like you kind of normally would by using a current divider. Now using a current divider, you know the formula is the current that you're looking for. If these were both like resistances, you can do these components. You would do the impedance of the resistor, which is in the numerator, over the sum of the two components, which is the resistance and the capacitance. Now, big mistake here is to usually people put like the impedance of the capacitor in the numerator, but remember, for a current divider, it's the opposite component that you're looking for. So we'd have to do it for the resistor. And don't forget to multiply by your current source of the system. So remember, key mistake, people usually put ZC on the top instead of ZR. Next, the following relationships are for impedance. Impedance is kind of like resistance, so the impedance of a resistor is R, the resistance. The impedance of an inductor is the derivative of the inductance, and the impedance of a capacitor is the integral of the impedance. Is the integral of the 1 over the capacitance. Excuse me. So these relationships you should know. If you don't, again, watch that video on total impedance. And then you can simply use those relationships for this formula. So ZR is R, and then ZC is 1 over CP. Now, just use algebra to simplify this equation here. You can multiply by CP over CP. The CP cancels in the denominator to give 1, and then CP times R is just RCP. So then you would have to do that to the numerator as well, as shown. So then you have that equation. Then what we do is you have to make the whatever is attached to the p in the denominator, you have to make that coefficient equal to 1, kind of like with dealing with quadratics. You want to make the a term 1. So in this case, we just divide by RC to both sides, and you just get p plus 1 over RC in the denominator, and again you have to divide by RC in the numerator, so the RC cancels and you get p over p plus 1 over RC times the current source. And that's actually our answer. So that is pretty much how you write the operator equation for this circuit here. Now if for those of you who are a little struggling with the math, if the math was difficult to follow, simply pause the video right now and you can look at the more in-depth approach to solving this algebraically. This is a pretty quick way though, if you're comfortable with your algebra. Alright, I hope this helps for you all to kind of write the operator equation instead of using a differential equation to make life a little bit easier later down the line. I hope it helps. Good luck and happy studying.